All right, this lesson kind of continues on with 2.4 where we talked about writing equations of lines. We're going to get into specifically what direct variation is. All right, so two variables x and y show direct variation provided if you have y equals kx, and this right here should say does not equal 0. The non-zero constant is called the constant of variation. Constant of variation. Okay. And y is said to vary directly with x. So k is the constant, and y is said to vary directly with x. So the variables x and y vary directly. So they tell us that to start out with this one. And y equals 19.22 when x is 6.2. Write an equation that relates the variables, and then find y when x equals 8. So we're basically finding the slope. So there's a couple steps to this. The first step is find k. Using y equals kx. Okay, we can use that equation, or I just want to show that instead of y equals kx, you could do k equals y divided by x. That would also work. So you would find k. So in this case, if y is 19.22 and x equals 6.2, k equals 19.22 divided by 6.2. And 19.22 divided by 6.2 is 3.1. So k is 3.1. All right, so you find k, that's step 1. Step 2 is write the equation with k. Actually, I'll let you write this out. Write the equation with k. So what this would look like is you would say, okay, well, y equals 3.1 times x. So you find k, you plug k in the equation, just like the other lesson we found the slope and the point and we plug it in. And then the last step is plug in the new values. So I'm going to, instead of say plug in, I'm going to say substitute in the x value you need. So the x value that we need is x equals 8. So find y when x equals 8. So it would be y equals 3.1 times 8. So you plug that in. You plug it in. 3.1 times 8 is going to give you y equals 24.8. Okay. So if they don't tell us it varies directly, we might see questions like this. Does the data show a direct variation? If so, write an equation relating x and y. So what we're going to do is check for all. So if you want to know, does it use direct variation, we're going to check all k values. So check all the k values, and we're going to use k equals y divided by x. So for the first one, we would do 4.5 divided by 3. Okay, 4.5 divided by 3 is 1.5. Then we'll do 7.5 divided by 5. 7.5 divided by 5 is also 1.5. 16.5 divided by 11 is 1.5. And 22.5 divided by 15 is 1.5. So all the k values are 1.5. So they're all the same. If they all are 1.5, then it varies directly. So does this vary directly? Yes. And then it says to write an equation relating x to y. So we would say y equals 1.5 times x. Okay, and then that would show us if it varies directly. All right, and then the last thing we cover in this section is linear models. Okay, a linear model uses independent variables and a dependent variable. The independent variable is the input, or the x value. The dependent variable is the y value, or the output. So in 1991, there were 57 million cars. It shouldn't say cars, it should say cats. Whoops, typo. So 57 million cats as pets in the United States. By 1998, this number was 61 million. Write a linear model for the number of cats as pets. Use the model to predict the number of cats as pets in 2012. Obviously, this question was made a long time ago, since 2012 was 8 years ago. But we're going to do the problem nonetheless. So x and y. So x is the independent variable. So in this case, it's going to be the time. So x is going to be years since 1991. Okay, that's what we're saying is independent. The years don't depend on anything. The years just keep on going on. All right, and the dependent variable is going to be the number of cats. Right, because we're saying that as the years go on, the number of cats gets bigger. So the number of cats depends on the years. Okay? So we have two ordered pairs. We have one that comes from 1991. 1991 is 0 years after 1991, and there are 57 million cats. So that's our first ordered pair. Okay, and then we have 1998, there were 61 million cats. So 1998 is 7 years after 1991, and there were 61 million cats. So we have two ordered pairs. So we have an x1 and a y1, and we have an x2 and a y2. So we're going to find an equation that relates these. So first, we have to find the slope. The slope would be 61 minus 57 divided by 7 minus 0. So our slope will be 4 over 7. Okay, which is, I'm going to put or 0.57 roughly. You can use either one, 4/7 or 0.57. So if the slope is 0.57 or 4/7, now we got to write our equation. I'm going to pick a point from here. So I'm going to pick my first point, my x1, y1. And I'm going to use my point slope form. Okay, so it would be y minus 57 equals 4 over 7 times x minus 0. Okay, we will do distributive property. Y minus 57 equals 4/7 x. And 4/7 times 0 is just 0, so I'm not even going to write that down. And then we add 57 to get y equals 4/7 x plus 57. So that's the equation that relates it. And then if you want to find out how many cats you had in the year 2012, so in 2012, all right, that would be 21 years after 1991. So you do y equals 4/7 times 21 years plus 57. Okay. Okay, so I'm going to plug in my calculator. 4 divided by 7 times 21 plus 57. So it looks like y equals 69 million cats as pets in 2012 is what we get. Okay, so linear model is just used to predict things in the future. In this case, we predicted how many cats would be at Pets in 2012. Obviously, you could look this up to find out if it's true, but we're just kind of showing that how math can predict things in the future.